This lesson is entitled Limits that are Positive or Negative Infinity. That is, the limit of a function given as x approaches some real number is either infinity or negative infinity. Is undefined the same as does not exist? That's a question we're throwing out here in the beginning, and we hopefully will address that question as we go through this lesson. Let's look at this function. F of x is equal to 1 over the quantity x minus 3 squared, and we want to find the limit as x approaches 3. Now, in a limit problem, the first thing you do is you substitute in the value you're approaching. For us, that's x equals 3. You should realize in this particular problem, you cannot substitute in 3, nor is there a way to cancel out this troublesome term that's giving us the 0 in the denominator, x minus 3. Now, that should mean that the limit probably does not exist based on earlier topics, specifically a lesson on finding limits when given an equation. You may or may not have seen that lesson, but if you have, you may recall it. And if not, maybe you'll look at that lesson. And this is true still in this lesson. We use terms, limit doesn't exist, but we want to fine tune that answer in this lesson. So let's go back to the problem, and the only thing we have that we can do is choose a number close to 3, and we're going to choose numbers to the right. So we'll start with 3.1 and put that in, and when we do, we get 3.1 minus 3, which is 0.1, which is 1/10, and we'll square it. 1/10 squared is 1 over 100, and when you divide, you invert, so that becomes 1 times 100 over 1, giving us 100. Likewise, when 3.01, you subtract 3 from it, you're going to get 0.01, which is 1 over 100. When you square that, you get 1 over 10,000. And when you invert and multiply, you get 10,000. And by the same token, 3.001 is going to give you 1 million. And it looks like it's trending towards infinity. And that's what we're going to declare the answer there is infinity. When you pick a number to the left of 3, say 2.9, and substitute that in, that's going to give you 2.9 minus 3 is negative 0.1, negative 1/10. But when you square negative 1/10, you're going to get positive 1 over 100. And when you invert and multiply, you'll get 100. And likewise for 2.99, you're going to get 10,000, and 2.999 is going to give you 1 million. And so it looks like it's trending towards infinity. And since the limit to the left and limit to the right are the same, based on the earlier lessons, we can say the limit is infinity. And there's a graph of this situation that seems to support that on both sides of 3, it's going upward towards infinity. Let's take another function. G of x is equal to 1 over x minus 3, and find the limit as x approaches 3 here. And again, for the same reason, you cannot substitute in 3, so we'll try a number to the right of 3, which is 3.1. And when we put 3.1 in, we get 3.1 minus 3 is 0.1 or 1/10, and 1 divided by 1/10, you invert and multiply, gives you 10. 3.01 is going to give you 100. 3.001 will give you 1,000. And this too is growing, certainly not as rapidly as the previous example, but we're still going to declare that it's going towards infinity. Now, when you put a number to the left of 3, 2.9, you're going to get 2.9 minus 3. That's going to give you negative 0.1 or negative 1/10 or negative 1 over 10, which when you invert, is going to give you negative 10. And the same thing will happen here. It's going to give you negative 100. And this is going to give you negative 1,000. So we're going to declare that we think it's going to be trending towards negative infinity. But because they're not the same, we have to say that the limit as you approach 3 here for this particular problem does not exist. Again, based on the previous lesson on limits. And there's the graph which supports that. to the right, positive infinity, to the left, negative infinity. So there are your two functions here. We want them in front of us to look at, and we're saying dissect them. We want to see what's going on here so that maybe we could get the answers without actually doing arithmetic as we did in that particular problem. Now notice, read along. Example 1 went to infinity on both sides, and so the limit was infinity. Whereas in this problem, it went to infinity on one side and negative infinity on the other. And since they're not the same, we said the limit does not exist. Both examples have 1 as a numerator, but we really aren't interested in that. What we're really interested in is that the numerator is positive. Keep that in mind. The numerator in each of these problems is positive. So all we really have to worry about is the denominator. Now, the denominator is always positive in example 1. Why? Because we're squaring it. Okay, so the denominator is always positive in example 1. The denominator is positive to the right of 3 in example 2, but negative to the left of 3. They're not the same. So the fact that these were positive on both sides, they were the same, meant the limit exists. This one meant that the limit did not exist because they weren't the same. Just as an aside, when you raise a quantity to an even power, and 2 is even, you're going to always get even. All positive, I'm sorry, you're going to always get positive, okay? Let's restate that. When you raise a quantity to an even power, and 2 is an even exponent, you're going to always get a positive. When you raise a quantity to an odd power, and 1 is an odd power, you say, what is odd? What is a power? It's the power 1. You get a positive if the quantity is positive and a negative if the quantity is negative. We need those facts. They will help us when we're looking at the subsequent examples we're going to be looking at so that we don't have to do the arithmetic. I want to answer one question that you may have. It's not germane to what we're doing here, but you may be noticing. Did you notice that this function went up very quickly? 100, 10,000, 1 million. This one, however, went up to, when we put in a number to the right of 3, we got 10, 100, and 1,000. Now, why is that happening? Well, it's when you raise a number to a power, if the number is bigger than 1, when you raise a number to a power, the answer is larger than the original. In other words, if you have a as a number, then a squared is bigger than a if the number is bigger than 1. But if you have a number between 0 and 1, when you square the number, it gets smaller, i.e. 1/10. When you square it, becomes 1/100. And that's because, and all of our numbers, since we're taking very close, are going to be small numbers, just slightly more than 0. So that's what's going on. I don't know if that is necessary to say this, but as we were developing this lesson, we thought that might be something that you are thinking about, and we will answer that for you. Now we want to look at some exercises. In most exercises, you do work and then you give the answer. And these exercises, you want to think for the most part and give your answer. The exercises build in level of difficulty. Now we have in parentheses, build in level of difficulty, because we're going to see that, are they really building in level of difficulty? Keep that in mind. So here we have example 1. What's the limit as you approach 7 from the right, from the left, and what's the limit as you approach 7? What we're doing is walking you through this. In other words, nothing has to be done to get this answer. This answer is dependent on these two answers, okay? So a number to the right of 7, we're going to think of 7.1. And a number to the left of 7, we're going to think of 6.9. So let's put 7.1 into this. When you do, you get 7.1 minus 7, which is 0.1 cubed. And we don't care what that is. All we care is that it's positive. So you get a positive over a very small positive number, and that's going to give you a very big number. And positive over positive is going to give you infinity, okay? On the other hand, when we trace 6.9 into this, we're going to get 6.9 minus 7 is negative 0.1. And when you cube a negative, you're going to get a negative. So it's going to be positive over a negative. And it's going to be very close to 0, but it's going to be a negative. And that's going to give you negative infinity. Now, since this is infinity and this is not in, this is negative infinity, they are not the same, so we say the limit does not exist. So we don't do any work by answer C in these exercises. Example 2. Basically, we're still going towards 7, so we're going to use 7.1 and 6.9 as our test points. But this is 1 over x minus 7 to the 6th power. So when we turn the number to the right, we put in 0.1, we subtract 7.1, we subtract, we get 0.1. 0.1 raised to the 6th power is positive, small positive number. This is positive, just like before, so it's a positive over positive, gives us infinity. Now, when we put in 6.9, 6.9 minus 7 is going to give us a negative 0.1, but negative 0.1 raised to the 6th power. Remember, we said earlier, a negative raised to an even power is going to be positive. So this will be a very number close to 0 that's positive. And we divide it into 1, so we're going to positive divided by pi. Again, we get infinity. And since both of these are infinity, the limit this time, since they're the same, is infinity. Let's look at example 3, where we're going towards a different number this time, but also the numerator is not the number 1. So we're approaching 4 from the right. So 4 from the right, we're going to use 4.1, and 4 from the left, we're going to use 3.9 as our test values. But now this numerator is, the 4 in the numerator is no problem. The 4 in the denominator is a problem. 4 minus 0, 4 minus 4 is 0, 0, 0. That's the problem. But there's no problem having 4 in the numerator. 4 minus 3 is 1. 4 minus 3 is 1. 1. And so the numerator is, again, we don't care that it's 1, it's positive. So all we've got to do is worry about the sign of the denominator. Now we choose a number to the right of 4, if that's 4.1, that's going to give you 0.1. So it's positive, positive over a small positive number. Signs are like infinity. Okay. When we put in 3.9 and subtract 4 from it, we get negative 0.1. That's going to be a positive over a negative. Okay. Which is going to be negative infinity. And since they're not the same, that's going to be does not exist. Let's look at number 4. Now, this time we're approaching a negative number. That was by design here. Again, what we're approaching is negative 4. Now, remember, when you put a number near negative 4 into the numerator, or put negative 4 into the numerator is going to be negative 4 plus 3, negative 1, negative 1. It's going to be negative. The numerator is going to be negative. So all we've got to do is worry about the sign of the denominator. Now remember, when you approach negative 4 from the right, think about it on the number line. This is the number from the right, negative 3.9. Think of it on the number line. Negative 3.9, negative 4, negative 4.1. This is the number to the left. So we're going to use this number. Now remember, the numerator is negative. Negative 4 plus 3, negative. Keep that in mind. So when you put negative 3.9 into this, you're going to get 4, and negative 3.9 is going to be positive 0.1, is it not? So what we're really interested in, if we have a negative over a really small positive number, that's going to give you, we have a negative numerator, a positive denominator. Positive over a negative, or a negative over positive is a negative. So it's negative infinity. Now, when we put negative 4.1 into this, we get negative 4.1 plus our 4 is going to give us a negative 0.1. But this is a negative, so a negative over a negative is a positive. So they're not the same. One's negative infinity, one's positive. So we answer this by saying does not exist. You may want to listen to some of this a second time, but that's what we'd like for you to be able to do, is maybe take a few notes, but not actually put in, like we only put in 4.1, but the same thing is going to happen if I had put negative 4.01, negative 4.0, and so forth and so on. Okay, so keep that in mind. Now, number 5 here looks like a much harder problem. And as it stands, it's an A-level problem, I guess. This one's going to be harder to do in our heads, and I'm not looking forward to it. But wait a minute. Look at this. Minus x minus 3 over 4 minus x. A minus sign in front of a fraction, you can remove that minus sign if you change the sign of the numerator or the denominator. So what I'm going to do is we'll leave that numerator alone, and I'm going to multiply the denominator by -1, which makes that -4 plus x, or x minus 4. Now, this is not a really hard problem. In fact, it's one of the easier problems. We just gave you this. This is certainly no harder than problem number 3. We can put 4 into the numerator because 4 minus 3 is 1. That's no problem. And so when we pick a number to the right of 4, say 4.1, then we're going to get a 0.1. That's going to give me a positive over positive is infinity. When we put 3.9 minus 4 is going to give me a negative. That's going to be positive over a negative. That's a negative. And since they're not the same, the limit doesn't exist. So what we have here, that's why we put it in parentheses. It looks like the problems are getting harder, and they are. However, if you see this, now, do we expect you to see this? I don't know, because we don't know you that well. But you'll never learn these tricks unless you are exposed to them, and then you start looking out for them. I guess what we're trying to say is when a problem seems to be a little more difficult than you think it should be, maybe there's some way that you can make the problem not so difficult, and that's what's going on here. Now let's look at example 6. This is a polynomial of a polynomial, and it looks like, and we want the limit as x approaches 3, and we want the limit as x approaches -2. And this looks difficult. Let's work on the first part, x approaches 3. Now let's look at this problem, though. Before we do, let's see if there's something we can do with this problem. This numerator factors, does it not? X plus 3 times x minus 2 is going to give you x squared plus x minus 6. And so is this denominator factorable. This is going to give you x minus 3 times x plus 2, because when we FOIL this, we get x squared minus x minus 6. Now, let's concentrate on approaching 3. When you approach 3, look at this. When you approach 3, this is going to be, when you put in 3, there's no reason I can't put in 3, so that's going to be 6 positive, and this is going to be 1 positive, and positive times positive is positive. So the numerator is going to be positive, and likewise you can put in 3 here, and that's no problem. That's going to be 5. So this is positive, and this is positive, so all we have to worry about is the sign of this. So if this is negative, the whole thing, since this is positive up here and this is positive, if this is a negative, it's going to be negative. But if this is a positive, it's going to be positive. So let's, if we take a number now, we're approaching 3 from the right, from the left. So a number to the right of 3, this is going to be positive. So based on what we see, this is going to be positive infinity. When you take a number to the left of 3, like 2.9, this is going to be negative. Since all of this is positive and this is negative, that's going to be negative infinity. And so they're not the same, does not exist. So that takes care of A, B, and C. Now, D, E, and F, we're approaching -2. Now, -2, when put into this, is going to give me a 1, and -2 into this is going to give me a -4. And so this is going to be a negative. The numerator is going to be negative. And when I put a negative into this, I'm going to get a negative. Am I not? So this is going to be negative no matter what I put in, close to 2. Okay, -2, I'm sorry. And this is going to be likewise a negative. So all we have to do is worry about the sign of this thing right here. And it turns out, so if we take a number to the left of negative, right of -2, which is -1.9, this is going to be a positive. And since this is negative over negative is going to be, that's going to be positive. And then when I put in a number to the left of -2, say -2.1, that's going to be a negative here. And so the thing is going to be negative. So that limit does not exist either. So this is a pretty tricky problem. If you have to work from here, basically all you could do is cut your losses and put a number in, I guess, or really do some mental gymnastics. But when you write it like this, now this is really, so that you won't be scared off from the topic, getting into 5 and 6 more challenging problems. But we're interested in getting across the topic. And so hopefully you saw what was going on in the previous problems. And let's go to the last problem, which is number 7, which looks like, well, what's going on here? We're approaching 4, so that's not bad. It's not a negative. And what we're going to do here, well, what am I going to do? Well, you have to recognize that this thing is really this thing. Square this, square the first term, x squared, multiply the two together and double, -8x, square the last term. That's your shortcut rule for squaring a binomial. So this is going to always be positive. Why? Because you're squaring. So all we have to do is worry about this number up here. And so this is going to be positive, is it not? This is going to be positive because 4 plus 3 is 7, which is positive. So this is going to be a positive. This is going to always be positive. So the quotient is going to always be positive. So it's positive. So positive, positive. So if you saw that, then it's a pretty easy problem to do. It's all in how you look at the problem, but you may want to listen to this again to fine-tune your own thinking on this. Some concluding remarks. Algebra taught us where a function has a vertical asymptote. Calculus shows us in which direction the graph follows along the asymptote. In other words, all you do in algebra when you say something, it's undefined, it denominator is x minus 6, undefined is 6, tells you there's an asymptote of 6, and there is for us too. But now the calculus shows us what direction the asymptote is going, whether they're both going in the positive direction, both going in the negative direction, or one positive, one negative. Okay. This topic gives us another tool in our toolbox when it comes to sketching a graph. And so looks like we're at the end of the remarks here. And so this should conclude this lesson.